Good morning. Today we are going to continue in Unit 11. We are going to be talking today about geometric sequences. So go ahead and get started. If you don't have a bell ringer paper already, go ahead and grab one and complete these bell ringers. Please have 2 people go up to the board to complete these problems. And then pause the video, and then when you're done, come back and we'll check our work. Okay, so for this first one, we are going to start by writing the formula, or writing the formula for what's happening in this arithmetic sequence. So to get from 10 to negative 9.3 and from negative 9.3 to negative 8.6, etc., we are adding 0.7. Each time we're adding 0.7. And I know that we've got negative, 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 but really these numbers are getting closer to 0. So that's how I know that we're moving in a positive direction. We're moving, if we look at our number line, we're moving in this direction, so it's a positive number. And so my first term is going to be negative 10. My D value is going to be 0.7. So I'm going to write A sub n equals, and remember we do A sub 1 plus n minus 1 times D. Well, I'm going to substitute in the values I know. I know negative 10. And then I'm going to put plus n minus 1 times 0.7. And then I'm going to say, all I need to really find is the 26th term. So I'm going to say A sub 26 equals negative 10 plus 26 minus 1 times 0.7. If I do a little bit of math here, I'm going to get 26 minus 1, which is 25. 25 times 0.7 is going to be 17.5. So we're going to have negative 10 plus 17.5, and that's going to give us that A sub 26 is equal to 7.5. For this second one, I'm looking at what rule is happening here, or how am I getting from 23 to 17, 17 to 11, etc. And this time we're going to be adding negative 6. Or we could just say minus 6. So A sub 1 is going to be 23, because that's our first term. And our common difference is negative 6. So I'm going to have A sub n equals 23 plus n minus 1 times negative 6. Again, remember we need, especially with negatives, we need to put it in parentheses so that we remember that we're not doing n minus 1 minus 6. It's got to be times negative 6. So if I substitute in, again, this 26 that we're trying to find, the 26th term, the 26th term is going to be 23 plus 26 minus 1 times negative 6. And that's going to give us 23. 25 times negative 6 is going to give us negative 150. And if we subtract those, we should get that A sub 26 equals 127. Negative 127. So make sure you've got those copied down before we move on. And here we go. So, yesterday we looked at arithmetic sequences, which is when you add or subtract the same number. Today we're looking at geometric sequences. So a geometric sequence is a sequence with a common ratio between consecutive terms. In other words, it's to get from one term to the next. Oh, that should be a marker or pen, sorry. In other words, to get from one term to the next, we multiply or divide by the same number each time. So for example, here I'm multiplying by 3 to get from one number to the next. I'm multiplying by 3 every time. If I had something like 16, 8, 4, 2, etc., I could say, oh, I'm dividing by 2, but we want our common ratio to always be in terms of multiplication. So really what I'm doing is I'm multiplying by 1/2. I'm multiplying by 1/2. And we'll look at that again in a minute. Either of these, if it just asks for the rule, either of those are correct, but when we're writing our common ratio, it should be 1/2. It should be what you multiply by. All right, so determine whether each of the following sequences are geometric and justify your answer. So how do we get from 6 to negative 24? Since we're only testing for geometric and not just saying is it arithmetic or geometric, since it's only geometric, we're going to test the multiplication. So test multiply. So what do I multiply 6 by to get negative 24? I multiply by negative 4. What do I multiply negative 24 by to get 96? Well, I multiply by negative 4. And that rule is going to hold every single time. I'm going to multiply by negative 4. Then if I look, so I'm going to say, yes, this is geometric. And the common ratio is negative 4. This right here qualifies as our justified answer. There's a common ratio, so that means that it's geometric. So that would be sufficient. If I look here, I'm saying, what do I need to multiply by? Well, if you're looking at that and you're saying, well, 8 doesn't go into 20 evenly, the one thing that we can do is to say, I'm going to take 20 and divide it by 8. Well, that's going to give me like I think it's like 2.6. So we're saying I'm going to multiply by 2.6. Well, then how do I get from 20 to 32? If I do 20, I guess it's hold on. I guess it's actually 2.5. If I do 20 times 2.5, does that work? If I do 20 times 2.5, I actually get 30, not 32. And so this rule does not work. And so we would just say no, and we can just say there's no common ratio. And that would be sufficient. So, just like with the arithmetic sequences, we can write a recursive formula pretty easily. We can say, okay, our recursive formula would be this. Ooh, that's not the best color to use for highlighter. A recursive formula is easy to write because we just take the previous term and multiply it by our common ratio. But just like with the arithmetic problems, we are still going to run into the same issue where we have to know the previous term. And so if I want to find the 72nd term, I have to know the 71st, and then I have to know the 70th, and it just becomes a really messy cycle. So we want the explicit formula, and that's where we're going to use this. A sub n equals a sub 1 times r to the n minus 1. And my a sub 1 is still going to be the first term, and the r is still going to be the common ratio. Okay? So, find the 19th term in the sequence. Well, first I'm going to write my formula. I know that a sub 1 is 11, because that's my first term. And then I'm multiplying by 3 every time, so my r is going to be 3. So what I'm going to do is I'm going to say, okay, a sub n equals 11 times 3 to the n minus 1. Right there, I've got my formula. If I say, write the formula, boom, I'd be done. I cannot multiply 11 and 3 first. I have to take care of this here first, okay? I see too many people who do 33 to the 19 minus 1, and it makes me cry every single time. So we're going to plug in 19, and we're going to get 11 times 3 to the 19 minus 1. So we're going to get 11 times 3 to the 18th. And if we do 3 to the 18th, got to put it in my calculator here, we get a really big number. We get 11 times 387,420,489. And so then I'm going to multiply that by 11, and I get an even bigger number. I'm going to say that a sub 19 is equal to 4,261,625,379. And this just shows how powerful geometric sequences are. They grow at such a faster rate. They grow at an exponential rate, actually, instead of a linear rate. And so your numbers are probably going to be a lot bigger or a lot messier, I guess, for geometric problems. So if I said find the 28th term in the sequence, I'm going to look at this and say, Okay, my ratio, what am I multiplying by every time? I'm multiplying by -6. Multiplying by -6 every time. That's what I'm doing. So that's my R value. My a sub 1 is just 1 because that's the first term. So substituting these in, I'd get a sub n equals 1 times, I'm going to put this in parentheses, -6 to the n minus 1. And the reason is, if I don't put the parentheses, if I raise it like 6 to the second power, it's going to, or -6 to the second power, we talked about this earlier, -6 to the second power is actually -36. So what we want to do is do -6 to the second power so that we get a positive 36. So those parentheses matter. So a sub 28 equals 1 times -6 to the 28 minus 1. Let's see if my calculator can even handle this. We're going to get -6 to the 27th. So to the 27th. Yeah, my calculator doesn't even like this. So yours probably is going to do the same thing where it's going to give you that E, but we're going to get 1.0235 times 10 to the 21st power. And what that means is that, and 1 times anything is just itself, so really I don't need that right there. But what it means is that I could write 10235, but I'm going to move this decimal point 21 spots to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So those would all be zeros. So if you want to write it like that, you can. Filling in each of those spots with a 0. But this would be an absolutely fine answer, because I recognize that that is that should be 27. That would be an absolute, no it shouldn't. That would be an absolutely fine answer there. Sorry, I was thinking about this 28 over here. Okay. Write the explicit formula for the sequence given by the following information, then write the first 5 terms. So they're already telling us what our a sub 1 and our R are. So then we're going to have a sub n equals first term times the common ratio to the n minus 1. And plugging it in, I'm going to say, okay, I've got a sub 1 equals 5 times -2 to the 1 minus 1. So that's just going to equal 5. Because this would give me 0. -2 to the 0 power is just 1. So really, whenever you plug in a sub 1, because you're going to have 1 minus 1, it should always just be whatever your first term is. A sub 2 equals, now we're going to do 5 times -2 times 2 minus 1. 2 minus 1 gives me 1, and -2 to the first power is -2, so I'm going to get -10. A sub 3, 5 times -2 to the 3 minus 1. -2 squared is +4, so I'm going to get 20, +20. A sub 4 is going to be 5 times -2 to the 4 minus 1. So we're going to get 5 times -8, which is -40. And we should start to see a pattern happening here. We're just multiplying by -2, which we know is because of our common ratio. But we need to still check our work and make sure. So equals 5 times -2 times 5 minus 1. 5 times, that would be 5 times 16, which would give us +80. So there are our first 5 terms. And this would count as showing your work. So you need the formula and the work to show that. All right. So here we're going to do the same idea. Another way we could do this is just say a sub n equals 54 times 1/3 to the n minus 1. And we could say, okay, well, I know my first term has to be 54. They've already given it to me here. And then I'm just going to take that and divide by 3. So that's an easy way to kind of check your work. 54 divided by 3 would give us 18. Divide by 3 would give us 6. Divide by 3 would give us 2. and then that would give us 2/3. Homework.